There we go. Sorry about that, everybody. Hey, welcome back, everybody. We're here on Monday here. Still not all set up here. Hold on a second. Let me get this cleaned up here. Listen, we're going to switch things around. Hello, everybody. Hello, Emily. Hello, Kennedy. Welcome back, everybody. There's a new weekly assignment sheet up for you today. Hello, Sam, Alex, Abby. Hello, Sharon. Hello, everybody. I was working on the actual presentation for today. I was working on our updated Niels Bohr and Einstein presentation this morning, and then I was an idiot and I deleted it. I didn't realize I had not saved it as a new file, and then I deleted my work, and then I got rid of my presentation for today. And so that's not your problem really right now. It was pretty good, trust me. So I don't know what are you gonna do? And so what we are going to be doing instead is we will be working through the stoichiometry problem for the assessment this week. Instead, that's not a big deal. We can do that today instead, and then I will recreate my. Well, it was pretty good too. I was pretty good. I'm kind of sad. I will recreate my updated Bohr Einstein presentation, and then we'll go over that tomorrow. So just to tell you what's going on then this week, there is going to be an assessment this week. We're going to be doing we're going to be kind of combining our stoichiometry assessments. Normally they would be a test on just regular stoichiometry, and then there would be a test on limiting reactants. What we're going to do differently this year is we're just going to combine it into just one assessment. And so I will show you the template for that. In essence, you'll be doing exactly what I'm going to be doing here with your own reaction. So you're going to be starting with varying amounts of two different reactants and then really running the table, as I like to say. And so I was going to do this later, but I will instead, since I deleted my presentation for this morning and I did not have enough time to remake it, we will walk through this because I know people had some questions about stoichiometry. As we are going through this, feel free to work ahead and try to solve the rest of the problem before I get to it. Watching me do a stoichiometry problem is not probably the best way to spend your time. So work ahead. And as I walk through this, I'll talk about how you're going to be graded on this. Essentially, what's going to happen is I'm going to release to you a document with about 150 unbalanced equations. Each of you are going to put your name beside one of those equations, and then you're going to essentially create your own limiting reactant problem. You're going to come up with two reasonable masses or masses for each of the reactants, and then figure out what the limiting reactant is, and then work through the problem. You are going to take pictures of your work, embed it in a Google Doc, which you've shared with me. And that way I can actually comment on your work. I'd rather you just, work it out on paper and take pictures and then insert those pictures into a Google Doc, as opposed to trying to type them into a Google Doc, which presents other types of problems. So that's it. That's going to be your stoichiometry assessment. I think it's individualized. It's fair. Obviously, if you need help with stoichiometry, there's no harm in reaching out to classmates or asking on the Google Hangout or asking me. I just don't want other people solving your problems for you. So I will give an updated information about that. There was another assignment due for tomorrow, and that's just simply put a scientist quote in the Google Hangout. I see that a lot of people are starting to do that now. I see Anthony's quote. I see Sam's quote. Shomik's got a quote in there too. So just make sure that you are, checking into the Google Hangout. I think it'll be a nice place for us to touch base as a period. But that's it. So since I deleted my excellent Bohr and Einstein updated video, I will do some stoichiometry. If you have any questions, obviously ask them in the chat as we go along. And then you can use this as a guide for Friday's assessment. It'll be due before office hours on Friday. And so what I did is I picked, let's see if this is working now. Again, I had to sort of switch gears here. Oh yeah, so this will be due Friday before office hours. So what I did is I picked one of the simpler problems off the page because I know you guys wanted to have the longer and more exciting problems for yourself. I'm going to encourage you guys. Oh, it even says, hold on, let me fix this up here. My daily update is wrong. Let me correct this. Give me 1 second here. Stoic review. Still learning. This is OBS, I think the name of this program is. This is how I'm live streaming. Okay, let me push this through. There you go. Does it say that now? Okay, it should say stored to view. I apologize for that. All right, so what we're going to do is essentially you're going to go through that worksheet and you're going to pick one of these equations. And again, let's all work through this one together. I would encourage you to pick out the toughest problem you think you can handle. And that way, that'll be a nice review for you, a nice practice for you. Some of them do have more than 4 chemicals. Obviously, that's for the super ambitious of you. Some of them even have more than 2 reactants, which would require a little bit more work just because you'd have to figure out which of 3 reactants runs out as opposed to 2. And again, I'm going to let you sort of self-select the problems that you want. Again, this document is not available yet, but it will be. And so what you are going to do is you are going to take your thing. Let me get this ready to write here. I think this is now, uh-oh, hold on. Uh-oh, there went it all, hold on. Now you can see the view out my window, everybody. Just hold on a second. Hold on, let's get this back out here. There's the pen, there we go. All right, so here's what we're going to be doing. We're going to be working through this problem. Now, all you're going to do is get one of these equations, and then what you are going to do is you are going to set up your own relevant information. And you are going to just come up with reasonable values for the reactants. So for this problem, for instance, I said, okay, let's pretend we have 212 grams of zinc, and let's pretend we have 313 grams of hydrochloric acid. Now, again, you do not have to pick those numbers. Please do not pick those numbers, but pick, reasonable numbers. If you want to put some prefixes in because you're sassy, go ahead and put some prefixes in. That's fine. It doesn't really matter. We're just going to run through this. But the idea is that you at least need the amounts of the 2 reactants or 3 reactants so you can figure out the whole problem. All right, and so that's going to be step 1 is just coming up with your relevant information. Step 2, you'll need to find the molar masses and you'll need to balance the equation also. I would always encourage you to find molar masses first so you don't accidentally wrap in your coefficients into your molar masses. Oh, hi, Lindy. Hi, Rachel. I didn't see you guys. Hello. Hello, Emily. Hello, everybody. And so again, what I would encourage you to do is find the molar masses. Now for Friday, I'm going to ask you to show the full molar mass workup for one of these. That means show the full factor label way that you find molar mass. The rest of them you can just determine back of the envelope. I think that's fine. So I'm going to just show you the work for finding the molar mass of zinc chloride. Again, we're making the assumption that we have 1 mole of zinc chloride. That's how we always find every molar mass. So I have 1 mole of zinc, right? And I have 2 moles of chlorine, right? And then I'm going to take those moles and I'm going to multiply them out. So I have 65.38 grams of zinc per 1 mole of zinc, right? And where do we get that, everybody? Where do we get that? I'll wait for the chat to tell me where I got that number. 65.38 grams, right? And then you have chlorine, and that's molar mass is 35.45 grams of chlorine per 1 mole of chlorine. Yes, the periodic table. Excellent, Alexandra. Very nice job. Very good. And so that's going to be 70.90 grams, right? And so again, when we add these up, we will end up with 136.28 grams. And remember, the moles comes back because we were making the assumption that we had 1 mole. I apologize. I'm blocking the units again. I can't really get out of the way there. I apologize. And so that's how you find the work for molar mass. Now for Friday, I'd like you to do that once. Okay, show me a full workup for one of the compounds more complex than a diatomic. So what have we already done? We've written down our relevant information. We found our molar masses. We'll write down the other molar masses on the next sheet. And then of course we're going to balance this. Most of you have already balanced this. To get this balance, we're going to need a 2 in front of the HCl. All right, so we'll go to the next page then, and we'll kind of get it set up from there, right? Oops, oh no, I went too far. I went all the way to the end there. All right, so again, what's the information we're keeping here? We've got 2 here. We've got our relevant information of 212 grams of zinc and 313 grams of HCl. right? We've got our molar masses. Again, zinc's molar mass is going to be 65.38 grams per mole. HCl, again, you guys can do the work for this, but this is going to be 36.46 grams per mole. We did the zinc chloride, right? Its molar mass is going to be 136.28 grams per mole. And obviously diatomic hydrogen is going to be 2.02 grams per mole. Again, for Friday, you only have to show the work for one of those. The rest of them you need to figure out. You can just use back of the envelope. You'll have to write that information down in your relevant information. All right, and so now that we've got our molar masses and our balanced equation, what we'll do is we'll take both of our reactants to a common product. Now, there are lots of ways to find limiting reactants. That's totally up to you. Again, you can take one limiting reactant to the other one. So the way I used to teach it is I used to say, okay, take zinc to hydrochloric acid, figure out how much hydrochloric acid you are going to need, and then subtract it, compare it to what you have there. If you like to do it that way, that's totally fine. I have found over the years that if students solve for a common product, they are less confused. Because not only is it just comparing apples to apples, whichever number is smaller is the limiting reactant, you're also killing two birds with one stone because you are then figuring out one of the masses you're going to need anyway when we run the table. By running the table, I mean we want to find, again, the mass of each reactant and each product so we can use the law of conservation of mass to check. So again, the way I like to do this is just take both of these and solve for a common product. I will solve for the easiest product, which is just diatomic hydrogen. But again, I encourage you at home, if you are playing along, don't do hydrogen, do zinc chloride. And you will find that even if you take both of them to zinc chloride, you will be ending up with the same limiting reactant that I am. So anyway, I'm going to start working through this. You can, again, work on your own. So again, I'm taking 212 grams of zinc. I am turning that into moles of zinc. So I'm taking 65.38 grams of zinc per 1 mole of zinc. I'm trying to make sure I don't write so far that I'm blocking it from you guys. I guess I could always take myself off the screen. And again, I'm going to diatomic hydrogen. That's a 1-to-1 mole ratio, right? And then I'm going to, again, take my moles of H2 to 2.02 grams of H2. Now, when you're on your own, you can take your molar masses off to whatever you'd like to take your molar masses off to. For Friday, we're going to take them off to the hundredths place just so we're all on the same page. And so when I do the math for this, I've pre-calculated this. I was able to get that done once I realized I had deleted my presentation for today. So that's 6.55. That's a terrible 6. 6.55 grams of H2. All right, so that's, again, we don't know if that's the limiting reactant yet because we still have to run the other one. So again, where did these numbers come from? I arbitrarily picked these numbers. You guys get to make your own reaction here. Pick out numbers that are relatively close to each other. Don't pick out numbers where it's going to be totally obvious what the limiting reactant is. That's not quite as much fun. And so again, we're going to run through the same problem here. We're going to take 313 grams of the hydrochloric, the hydrogen chloride. We don't know if it's hydrochloric acid right now. And again, we are going to take that and turn that into grams of hydrogen. So we're going to take the molar mass of hydrochloric acid. And again, feel free to work ahead, you ambitious students out here. I'm trying to, it's a little difficult for me to write on this drawing pad, but again, we're going to the same product. So the rest of this problem is going to look the same. And again, for you ambitious students who've worked ahead, you will get 8.67 grams of H2. And so again, the reason I really like solving for limiting reactants this way is that this is now super obvious what the limiting reactant is. Zinc produced less hydrogen gas, and therefore it's the limiting reactant. So what we're going to do is we're going to collapse this problem back to a regular stoichiometry problem with zinc as the limiting reactant, and we can just pretend we have enough hydrochloric acid. So if all I asked you to do was find the limiting reactant, you did it, and you also found out how much hydrogen is produced. There are simpler ways. Remember that if you're just trying to find out what the limiting reactant is, there's all kind of ways to just make even less work for yourself. You can just go to moles, because if you make less moles, you make less grams. You can go to reactant for reactant and figure it out that way. But if we're going to run the table, this is a nice important step. So we're going to remember this 6.55. This 8.67 is a fantasy. That number is really irrelevant at this point because it's not ever going to actually happen. Remember, we talked about that in class. If you've got 10 pizza dough balls and a truckload of pizza sauce, it doesn't matter how many pizzas you could make with that truckload of pizza sauce. You're only making 10 pizzas. And so now that we figured out what our limiting reactant is and how much of the hydrogen gas is produced, we really actually only have to do one more thing, right? We have figured out everything we need to do pretty much for this problem, except for what? Can anybody tell me what we probably still have to do? Actually, we have to do two more problems, actually. There are two more problems we have to do. We have to find what and what. Anybody want to add that to the chat? Tell me what two things we still probably need to find. I'm going to clear the screen here. Again, we're going to do everything now from our 212 grams of zinc. So again, we know, so what do we still need to find? Yes, that's exactly right. We need to figure out how much hydrochloric acid is consumed. And as Alexandra pointed out correctly, we have to figure out then how much is left. How much is consumed is not the same as how much is left. And then anybody else? Bueller? Anybody else? What else do we have to figure out? This is called wait time in the business. I'll start setting up the hydrochloric acid problem, and then you guys also figure out, this won't be enough. We're going to have to, we have two more stoichiometry problems we have to do. So I'll start setting up the zinc problem. So what we're going to do again is we're just going to treat this as a regular stoichiometry problem, right? And we're going to figure out again, very good, Lindy, very good, yes. And we're also going to figure out how much zinc chloride is created. Good, look at you guys, good for you. See that? We can still participate. All right, so anyway, so again, many of you have already worked ahead, so I'm going to be taking my zinc here, and I'm going to be turning that again into moles. I like to start every problem from the beginning. If you try to skip steps and start in the middle of a problem, you could end up cascading mistakes the whole way through, which is a big no-no. So take the extra time and just, set it up again. I don't think that's a big deal. All right, so we're going to now take this to the hydrochloric acid. Okay, what we're calculating here is, given the 212 grams of zinc, how much hydrochloric acid are we going to consume along with it? And so if we set up this problem, we end up, am I blocking this? No, good. We end up with 236 grams of HCl. So that is how many grams of hydrochloric acid is consumed by this reaction. And as we're going to point out, that's not how many grams of hydrochloric acid is left. So be careful with what you do with this number. All right. And then finally, the last thing we're going to do is we're going to take this zinc, as Lindy astutely pointed out. We're going to take the 212 grams of zinc, and then we're going to take it also to the zinc chloride. So you can start setting up that problem. Now, the one thing I want to point out, just to give you a little bit of time to work ahead here, is that you could technically start a stoichiometry problem with anything you solved for. If you wanted to start your next stoichiometry problem with hydrochloric acid, you could. The only problem is, if you calculated that wrong, you are going to calculate everything else wrong. So I would always recommend that you start with the given data. All right, so let's go. I gave you a little head start there. So I'm going to take my zinc. Again, I like to always start over. There is a mindfulness in this. There is a sort of Zen-like procedure of setting up a stoichiometry problem. So enjoy it. You know what you're getting into. There's nothing to get stressed out here. All right, so I'm solving for zinc chloride. I'm putting zinc chloride on the bottom. And again, label everything. Here's our molar mass that we determined. Sorry for the sloppiness here. All right, and then so I'll put that under here. That ends up being 442 grams of zinc chloride. So we've actually done all of the math that we had to do in this problem. We figured out what our limiting reactant was. We figured out how much hydrogen gas was being produced, and then we figured out the other two things. We figured out how much hydrochloric acid was going to be consumed and how much zinc chloride was going to be produced. If you see any mistakes in my numbers, please say something in the chat. And so what we can do now, and this is the thing that I didn't talk about much in the videos, but I did talk about a lot in class, is what we're going to do is make the ever important before and after chart. All right, so what we're going to do is we'll just leave this equation up here. I think the most important thing you can do for any problem is to show that you understand what all of these numbers mean, and you have all these things on your paper. So what we are going to do is make a before and after chart for this reaction. Again, I love making these. It really gives you the ability to solve this stuff. Uh-oh, did someone get a different answer than I did? 416. Well, you know what? Let's check that number then. I will add up. We'll add up our numbers and check to see if that number ends up with that. Thank you. I appreciate that, Sharon, for bringing up that number. Let's find out. Let's find out when we add up these numbers if I have made a mistake, which is very possible because again, I did this 10 minutes before the presentation because for those of you who are tuning in late, I deleted my Bohr and Einstein presentation. Now listen, I'm just going to explain why I did that. I'm so used to working with Google Slides, which retains everything. I didn't realize that PowerPoint was back to the old idea of an actual file. I'd gotten lazy and complacent. And so I accidentally forgot to create a new document. And then when I deleted my template, because I didn't need it anymore, I had actually deleted my work for today. And that's why I deleted today's presentation. But anyway, all right, so let's see what we have here. We had 212 grams of zinc to start with. We had 313 grams. Oh, did I put 69 instead of 65? Oh, if I did that, thank you, Rachel. I'm doing my calculations based on my original ones. So if I wrote something wrong on the PowerPoint that I'm showing you guys, I didn't write it wrong in my original calculations. So hopefully it'll match up. Oh, that's why she got the 69. Yeah, that makes sense. I apologize. Yeah, so I should have written 65 instead of 69 on that last slide. And that's why you're getting a slightly different number than I am. Yeah, sorry about that. Put the right mass in for zinc and that should take care of itself. Good, thank you. Thank you, everybody, for taking care of that. So I've got my two limiting reactants here. I've got my, obviously, I'm probably not going to start with anything. That would be a weird problem to actually start with product, but you could. It's not that much tougher. You would just add whatever you calculated to 0 instead of just making that your product. It would, again, it's like a cookie recipe where the cookie recipe says you're going to make, 3 dozen cookies, and then you're like, but I've already got a dozen cookies. That's fine. Just add it. And so we figured out that zinc was our limiting reactant, right? So there's going to be no zinc left. We figured out that we are going to produce 6.55 grams of hydrogen, right? That was our first stoichiometry problem where we did the limiting reactants. Oh, good. That's right. It was, yeah. So I wrote down, okay. So the mistake was on the last slide, I wrote down 69 once instead of 65. And that gave a few of you a different number. I apologize for that. Thank you for catching that, you eagle-eyed viewers. Right. And then we had, then we did 2 more stoichiometry problems. We figured out that we would be producing 442 grams of the zinc chloride, right? Remember that we're adding here, right? We're subtracting here, right? And now here's the big deal is we, for stoichiometry, predicted that we were going to consume 236 grams of hydrochloric acid. Now, the important thing, and this is the mistake that everybody makes, is this number is not how much is left, right? Remember that when you scale up a recipe, on allrecipes.com or something like that, if you don't need 1 egg, you now need 3 eggs. Again, that only tells you how many eggs you need in the recipe. So all we've done is scaled up our ingredients. Okay, so, you need 212 grams of zinc. All right, you need 236 grams of hydrochloric acid. The recipe has no idea how much you have or how much you have left. And so, again, we're going to have to do addition's tricky friend. And if you do that, this ends up being 77 grams, right? And so if we add up the top, I think it adds up to 525. And if you add up the bottom, it's a little different, but it adds up to about 525 grams, if I remember correctly. Again, if anybody wants to check it out, I think it's like 525.2 or something. And that's going to happen because we made a lot of rounding in this problem. So that's it. So there's one more thing we can do. We'll talk about that in a second. So what did we do? We figured out molar masses. We balanced the equation. We figured out the limiting reactant by solving for a common product. We then did the remaining stoichiometry problems from the perspective of the limiting reactant. Again, if you are an ambitious student and you pick one of the problems that has maybe 3 reactants, then you're going to have a little bit more work because you got to take all 3 to a common product. And if you pick one that has more than 2 products, obviously you're going to have to solve for those 2. But it's just more of the same. All right, so the last thing that you are going to do if we're going to combine these 2 exams is we have to do a percent yield problem. So percent yield, if you guys remember the equation, is simply the actual yield over the theoretical yield times 100%. Now, everything you do on paper is your theoretical yield. So we're going to stick with the zinc chloride in this case. So this 442 is our theoretical yield of zinc chloride. All right. And again, for the sake of argument, now I'm assuming this is going to be a pretty close to 100% sort of yield, but let's just say for the sake of argument that you actually only produce, what number did I use? 201 grams of zinc chloride. Okay, so the last thing we can do is say, okay, well, we only produce 201 grams of zinc chloride. What is our percent yield? Go ahead and see if you guys can, that's a pretty easy problem to figure out on your own. Again, we would just plug that in. Go ahead, you can tell me what the answer is before I even get done writing this, I bet. So you're going to take your actual yield, which you can only get by actually doing the experiment, and then you're going to divide that by your theoretical yield, and then multiply that by 100%. That's an important part of it because it gets the number to the right spot and then gets the units correct. So again, if you guys estimate, obviously this is going to be around 50%, but I'll wait for somebody from the chat to give me the answer. Now, for you guys at home, you're obviously going to have to come up with your own actual yield. I do not expect you to do these reactions. Please don't. But just come up with an actual yield that's less than, come up with an actual yield that is less than your theoretical yield. And yes, Sharon is correct. That is the answer that I got. I got 45.4% as my yield. Again, there's again, one of the things I know about honor students is A, they love maps. You guys love maps. And B, you love calculating grades. So let's just walk through that again real quick, and then we'll do some art for today and call it a day. So if we go all the way back, here we go. Here's our first slide here. So remember at the beginning, what did we do? We found our relevant information. We balanced the equation. We did molar masses, not necessarily in that order. You guys have to show the work for 1 molar mass. And then we did 2 stoichiometry problems for the common product to figure out which one of them made less of that product. And then we took the limiting reactant and then did all of the stoichiometry from that. Remember that in a regular stoichiometry problem here, just don't forget. So if you have a regular stoichiometry problem, right, A plus B yields C, right? In regular stoichiometry, we start with 1 and then we feed out to everything else, right? In a limiting reactant problem, right, we take, both of them and feed to a common product. So you're doing the same sort of math, you're just using it differently. All right? And then, so once we did that, we ran the table. We filled out the grid just to show that it works out due to law of conservation of mass. And then, since we got to squeeze all this stuff in, we did a percent yield. And that's absolutely everything you can do for this problem. The original assessment for this had you guys predicting the products, either a precipitation reaction or activity series or acid-base neutralization. And that was really fun, but it is what it is. There are plenty of good reactions for you to pick from. So these already have their products predicted. And again, I will make them available by noon today, probably. What you're going to do is go in there and sign up for a reaction of your choice. Please do not erase anybody's name. Please do not delete any reactions or anything like that. Just write your name, type your name next to one of those reactions, and then just do what we did. Take pictures of it, throw it in a Google Doc. If you want to break up those pictures based on each of those skills, that's fine. If you that's in fact, that might even be better. But as long as you take an all-inclusive picture, I should be able to find all of your work. Okay, and that's it. So that's our improv stoic review, because I deleted my presentation for today. And I'll tell you, that presentation really did need some upkeep. I've learned a lot about modern atomic theory since I made that lesson. All that stuff about relativistic mass, probably not appropriate. The stuff about E equals mc squared, again, not really relevant to what Einstein did for modern atomic theory. That was more the idea of the photoelectric effect. I know there are some people upstairs. You might hear some crying people. They are sad that our time together is almost over. All right. So, hold on. Got some fans calling me on my phone there. So anyway, so what we'll do is we'll wrap up today. It's time for terrible art improv. So what we'll have to do is we will have to finish up the rest of stuff tomorrow. Let's have some terrible improv art there. So good. Give me some ideas. I just actually answered that phone and then hung up on that person. I feel sorry about that person. All right, ready? Give me some ideas. A flower. I can do a flower. A flower. I need 2 ideas. A flower. I can do a flower. Classic idea. And a family. All right. Okay. All right. That's fine. All right. I can do a family pic. All right. So, okay. So we'll do. This is not going to be good. That's fine. Here's me. This is going to take too long. I'll make this quick. She's not. My wife's not going to like this. There's my beautiful wife. She doesn't look anything like this. All right. Okay. Well. All right. Let's just keep going. There's Enzo. He's doing well. Nope. I'm doing this quick because I don't think you guys want to sit here and watch me. There's Maya. She's not taller than Enzo, but oh gosh. How fast can you draw a terrible picture of your family? There's Luca. He's doing well too. And here's Jude the dude. He's got a lot more hair than this. There you go. That's a quick family picture. I did not want to spend a long time doing that because, your time's valuable to me. And there's a flower coming out of our... All right, listen, get out of here. I will post that. I will actually call back the person I hung up on. Sorry about that. And then I'll post the... thank you, Emily. Always a fan of my terrible art. And I will have the directions for your stoichiometry assessment up soon. And tomorrow we will Bohr and Einstein, since I didn't get to that today. All right, get out of here. Email me with questions. Thank you for watching and have a great day.